Hello and welcome to the class. By now, hopefully you've taken a look at the syllabus that was posted on WebCT, and you've seen that our textbook is Ragsdale Spreadsheet Modeling. Today what I'm going to do is our first lecture, which is an introduction to quantitative methods, and what we're going to have posted here on Rever will be PowerPoint lectures like this one today. We'll also have some webcam lectures where I'm going to be writing on a sheet of paper and drawing graphs and stuff, and the webcam will pick that up and present it. And we're also going to do quite a bit of Excel work with the spreadsheet. So let's start. First of all, this is a course on making quality decisions. Well, what is a quality decision? Is it one where the outcome is always satisfactory or the best outcome? Not really. You know, life is sort of a crapshoot. Sometimes you'll make a decision, you'll do all the right things, go through all the steps, and it may not turn out to be the best. So to make a quality decision, you're going to probably have some expert judgment and some quantitative analysis thrown in. The question is, how much weight should you put on your expert judgment and how much weight should you put on your quantitative analysis, where W1 and W2 are the weights that sum to 1, of course. And how do you become an expert anyway? Of course, you become an expert with experience, perhaps education. And of course the quantitative analysis, that's what this class is about. We're going to provide you a toolkit that you can use. So the question again, how much weight should you put on it? If you walk into, let's say, McDonald's and you're going to order lunch, are you going to use any quantitative analysis there? I suspect not, because no matter what you order, you're going to come out with that same feeling, as long as you stay within your budget. So when should you use quantitative tools? Well, you're probably going to use these tools when you have to make important decisions. Well, what makes decisions important? Well, if they involve a lot of money or lives. I've used this stuff in my personal life for trying to decide, you know, to buy a house or do certain things. So anyway, if it involves a lot of money or lives, it's an important decision, and you might want to think about using a tool. If your situation is complex, you'll more likely use a tool. By complex, I mean that there are variables that some of them you control, some you don't control. And if there are many variables, one rule of thumb says that the human mind can balance 7 plus or minus 2 items in their mind at one time, so from 5 to 9 things, and balance those in a decision process. But you know, many decision situations are going to have hundreds of variables, and there's no way that you could balance that many things and figure out a good solution. If the situation is repetitive, meaning that you know you're going to make this decision every week for the next year, you'd be more likely to use a quantitative tool, because once you've got that tool built so that it works, it should be pretty easy to revise the tool, set it, you know, put in the new input variables and let it run, and you should be able to have a pretty good outcome then. Of course, solution time comes into it. If it's going to take you a couple days to figure out a tool and you need a decision in 5 minutes, of course then it would be impossible to use a decision tool. So there's a trade-off. How much time should you spend modeling the situation versus what's the benefit of using that tool? There are some problems associated with quantitative analysis. One problem is there are going to be conflicting viewpoints within your organization. We kind of assume in this textbook that the organization has the same set of goals and values. That's not true. You know, most organizations, people have their hidden agendas and their pet projects, and they want to go their own way for whatever reason. Well, there are some tools, game theory, for example, deals with conflict, and there are some negotiation tools that are being developed now and group decision-making tools that assume conflict. But for the most part, this semester in this class, we're going to assume that everybody within the organization has the same set of values, and conflict is not going to be coming into the problem at all. Second problem is textbook model fit. You know, you're probably going to have some decision situations where you might say, well, that kind of fits what we would use linear programming for, or decision analysis, but it doesn't really fit 100%. Okay, so in that case, you'll have to use your judgment to figure out, well, do I use one of these textbook tools, or do I go out and develop my own tool, a new one? That's possible as well. But we're pretty much going to assume that these tools are out there, and that your problems are going to fit. Another problem is GIGO, which stands for garbage in, garbage out. Where does your data come from? In the textbook, we're just kind of assuming that the data is there. You know, if your garbage coming into the model, if your data coming into the model is garbage, then the output is going to be garbage as well. So you've got to be really careful about where you collect your data. Are you going to be using some data mining tools? Are you going to be using some kind of database, internal or perhaps an external database like the SEC's Edgar, or some other database? But in any case, you need to be aware where your data comes from and how accurate it is. The other thing is whether your decisions are strategic or tactical. Now, what do you think we have more quantitative tools, the strategic or the tactical? Turns out there's more tools dealing with tactical than with strategic. That might just be the nature of the beast, because tactical decisions are easier to deal with. Excuse me. Another issue is optimization versus satisficing. Optimizing is finding the best, maximizing or minimizing something, whereas satisficing is a term finding something that's good enough. Now, to optimize, we use optimization algorithms, and to satisfice, to find something good enough, we use heuristics. Heuristics are rules of thumb. Now, this is kind of related to Herbert Simon's bounded rationality. In fact, Herb came up with the term satisficing. Bounded rationality meaning we all have this box that we look to the world through, and we're limited by that box. We'll be discussing some DSS, decision support systems, and decision aiding. Of course, if you're developing a decision support system for a client, it's probably best that you get their involvement in the process. They'll be more likely to use the tools if they're involved. Likewise, you need to have communication skills to sell the stuff that you develop. We're not going to be really working on your communication skills in this class. Maybe mine, but not yours. But anyway, I do want to emphasize that communication skills are quite important. Some vocabulary terms: stochastic versus deterministic. We're going to be working with both kinds of models in this class. Stochastic, dealing in the realm of uncertainty, and we're going to use probabilities. Deterministic problems with the optimization, linear programming, dealing with certainty. There's no probabilities. So the first half of the class will be deterministic, the last half will be stochastic. We're also going to be discussing electronic commerce and dealing with some online tools as well. So that's it. That's the introduction. Next lecture will be on linear programming, and we'll go through an example problem of tables and chairs. Talk to you then.